So hi guys, today we will continue with probability with chapter 8. So in this probability, I will divide into three parts. So here's the first part, which is the definition of probability. So without wasting time, so just let's go. So before that, we need to know what is probability. Just let me do some simple explain, so as the definition is not important in our exam. So probability is the measure of the likelihood that an event will occur. It's a type of ratio where we compare how many times an outcome can occur compared to all possible outcomes. So it is quantified as a number between 0 and 1, where 0 indicates impossibility and 1 indicates the certainty. Like example, what is the probability to get a 6 when you roll a dice? So as you know that a dice has 6 sides. 1, 2, 3, 4, 5, 6. So the one side contains the number 6 that give us one outcome in 6 possible outcomes. So it will be written like this. Just one wanted outcome per 6 possible outcomes. So 1 per 6. And the random experiment is a process leading to at least 2 possible outcomes with uncertainty as to which they will occur. The set of all these outcomes which exhausts all the possibilities is called the sample space of the random experiment. We go to see the example. I give you there are 4 experiments. They have the outcomes and the sample space. So if I toss a coin once, it have a head and a tail. In Chinese, we call as gong and hua. So head will be the gong and tail will be the hua, if not mistaken. So the sample space will be S equals to this bracket, curly bracket, head, comma, tail. If tossing a coin toss, so I may get 2 head or 2 tail, or first head, second tail, or first tail, second head. So the sample space will rewrite is that this. If I roll a dice once, a dice will have 6 sides with number 1, 2, 3, 4, 5, 6. The sample space will be this. So I take a driving test. I may pass or I may fail the test. So the sample space will be S equals curly bracket, pass, comma, fail, close curly bracket. Event is a set of basic outcomes from the sample space and it is said to occur if the random experiment gives rise to one of its constituent basic outcomes. So like example, here's the sample space from a dice. So the total sample space will be 6. So let A will be the event getting value greater than 3. So the sample space of value greater than 3 is 4, 5, 6. The total value of event is 3. So if B will be the event getting at O value. O value you know as 1, 3, 5. So the total of them will be 3 or so. So the value greater than 3 and getting an odd number is the event. The probability of an event A occurring is denoted by P bracket A, where P bracket A can be number of successful outcomes divided by total number of all possible outcomes, or number of members of A divided by number of members of sample space, or be PA divided by PS. As A is a subset of S, so the numerator of this fraction is always less than or equal to the denominator. So for any event A, so the number of A won't exceed the number of sample space. Here's the rule. So the PA is between 0 and 1. So if PA equals to 1, so the event is an absolute certainty. If PA equals to 0, that means the event is absolute impossibility. So it's impossible to occur. So example, if one ball is taken from a bag, one ball is taken from a bag containing only red balls. So a possibility to take one red ball from all red balls. So the possibility will be 1. If I want to take blue balls, there are no blue balls, even though the pen is blue, but consider it as red first. I need to take blue ball, but there's no blue ball, so the possibility is 0. Just like this. So we go to a simple question. So a group of people consisting of 5 policemen, 3 clerks, 4 managers, and 2 directors. A person is randomly selected from the group. So what is the probability then that the person selected is first a policeman? So you need to five you calculate all the sample space. This I write the policeman as denoted as P, clerk as C, managers as M, and directors as D. So total number of policemen is 5, total number of clerks is 3, total number of managers is 4, and total number of directors is 2. So 5 plus 3 plus 4 plus 2, so equal to 14. So the number of sample space will be 14. So now I need to pick a policeman. There are 5 policemen, right? From the 14 people. So this is the possibility. The probability, sorry. B, a director. Director has 2 from 14 people. So I can simplify is 1 as 1 per 7. C, a clerk of a manager. Clerk has 3, manager has 4 from 14 people. So will be 7 per 14. 7 per 14, I can simplify it as 1 per 2. Here's the answer. Okay, now we go to some diagrams. So sometimes because the relationship between the events can be complicated, so it will be helpful to use the tools like Venn diagram, tree diagram, or contingency table to visualize and solve the problem of probability. So first we look at the Venn diagram. So like is it like A happens, so A will be shaded. A prime will be happen except A. So A won't be happen. So complement of A this like this hyphen. A subset B is A and B happen simultaneously. Both happen. If A subset B prime, so A happen but B does not happen. So you need to exclude all the B. So A union B is A happens or B happens. At least one happens. So they are considered. A prime subset B prime. So both A and B do not happen, so just the outside box. A subset B prime, A subset B prime union the A prime subset B. So only one happens. A not happen, B one happen. So either A or either B, but not both. So you need to exclude this total and this outside box. So here's an example. So here's rule, same as just now. So probability of sample size will be 1. So the event is between the probability of the event is between 0 and 1. So the complement of A will be denoted like this or this. So it will be 1 minus, can be written as 1 minus the probability of event also. We go to tree diagram, or it is known as the probability tree also. It is useful for calculating combined probabilities of sequence or events. For sequence, the important is for sequence. It helps you to map out the probabilities of many possibilities graphically without the use of complicated probability formulas. Like just now, the chapter 7, like calculating the number of ways, like 3 times 2 times 2 times 2. So there's including the sequence. So for this I use the tree diagram also. A probability tree has two main parts: the branch and the ends or leaves. The probability of each branch is generally written on the branch, while the outcome is written at the leaf. So example, a coin is tossed twice. Find the probability of getting at least one head. So here is the tree diagram for the toss of a coin. There are two branches, head and tail. So the probability of each branch is written on the branch with zero point 0.5 and zero point 0.5. Because you may either be head or tail only. So 1 per 2. So the outcome is written at the end of the branch. Here, here, here. We can extend the tree diagram to two tosses of a coin. So at least one head. So I just take this 0.25 plus 0.25 plus 0.25. So will be 0.75, at least one head. Let me write it here. It may be one head, one tail, or two head. Contingency table. This is I think I mostly like to use this. I like this table the most. So so why I like this? So later in the question I'll explain. A two-way contingency table shows the observed frequency for two variables in various categories. So each variables has categories or choice which are mutually exclusive or exhaustive. Exhaustive means the categories cover all the possible answer from each variable. So you just see the table. Right, this the exhaustive. Okay, so we go to a question. Because just like for easy to explain, so just pick one question that can involve all these three diagrams. Yeah, yeah, yeah. In a certain group of 100 students, so 54 study calculus, 69 study physics, and 35 studied both. So draw the Venn diagram, tree diagram, and contingency table by using the data given. So hence, find the probability of the student to calculus or physics. So is A union B. The students did not take either of two subjects. So the two circles outside. And C, the students took physics but not calculus. So first we draw the Venn diagram, the tree diagram first. For easier to look and easier to write, so we just write the physics denoted as F, the Malay physics, and calculus will be C. So the Venn diagram will be, yeah, just look back. 50, 35 study both. In this 54 study calculus, there are 35 students including inside the 54 students. So you need to minus 35 to get the number of students just study calculus only but not study physics. So it will be 19. So this also 69 minus 19, 69 minus 35, because here include the here also include the student study both. In order to find the student study physics only, so 65 minus 9, 69 minus 35, so I will get 34. And I minus all it. 100 minus 35 minus 19 minus 34. So I still left 12. This 12% this 12% does not study or neither the calculus nor the physics. So I just put the 12 at outside the box, outside the circle. For tree diagram, it's like the sequence. It like stress on the sequence. So we go to the physics first. The number of persons study physics is 69. National study physics is 31. Study physics and calculus both is 35. So physics but not calculus is 34. No physics, calculus only, no physics is 19. Does not study these two subjects 12. And the contingency table. The contingency table, just I include all. For me, I like the contingency table the most because the most detailed diagram among these three, because here you does not show the numbers. Here this two does not show the numbers. Add on this the total number of the physics plus calculus and physics without calculus. This 69, this 31, this 54, oh 54 have, 54 have. This 69 also have. These two data are not included in the Venn diagram and the tree diagram. So it's not so detailed compared to the contingency table. So for me, I like the contingency table the most. But the Venn diagram, I think the Venn diagram is most easier to draw. So depends on you, and depends on the question. Just ask both. Ask what. So if you want more detail, you can use contingency table. If like many data lah, like many data in it, the Venn diagram is, you cannot draw so many circles, so many circles, so many circles, right? If like for the dice question, yeah, the probability likes to use the dice question. You cannot draw six circles like this, right? So contingency table is most suitable for you to calculate for the dice question. So depends on the question lah. If like this, just just two outcome. So I just need two circles so Venn diagram can be used. So the student take calculus or physics. Calculus or physics, so can be 34, 34, 35, 19. So it will be 88 per 100. So simplify as 22 per 25. The second did not take either of two subjects. Here I have taken 12. So 12 per 100 can be simplified as 3 per 25. And the last, take physics but not take calculus. is here. This 34 per 100, so equal to 17 per 50. So here is the end of the part 1, and thank you.